Please pause the video and take a moment to read this important safety message.
Hey, welcome back everybody. Hopefully another fun video here today at Blue Glow Electronics. Trying a new mic out on the camera, so let's see how it works out for us. And what I've got here on the bench, if you don't recognize it, is a Scott 299D. Belongs to a friend of mine. He brought it over a few weeks ago. And he basically said, hey man, I've been recapping this unit, kind of restored it, and everything seems to work great except for one channel is louder than the other. And so those can be tricky little problems to diagnose. So I thought I'd just kind of walk you through the process as I go through it myself. And I thought I'd show you just the basic setup. First and foremost, I'll pan up here. I brought the unit up on a Variac. You don't need a Variac near as sophisticated as this, but I would say at a minimum have a Variac to bring an older unit up like this. Second thing I've got going on over here is I've got the output of this going into a dummy load. You could have it going into a speaker if you wanted to. You would just have to sit here and listen to it the whole time. And I've got it feeding into a dummy load, and then parallel across the outputs of that dummy load, I've got oscilloscope probes. So right now you can see I'm watching a 1 volt peak-to-peak sine wave that's coming out of this amplifier on one channel. And then the other thing, if I can swing on up here a little bit, I have just a 1 kilohertz tone going into it here from a signal generator on the input, which is ultimately driving the amplifier and getting that on the output. So a lot of people, you know, they ask me, I get this question a lot, what's the most basic set of, you know, things I need to do audio troubleshooting? And that, what I just showed you, along with a good quality multimeter, and you don't have to spend a fortune. I use this little EX Tech a lot, and it's about a $35 unit or so. Those are kind of the basics, along with things like soldering iron tools, screwdrivers, pliers, things that, you know, typical household tools. But you do need a way to kind of put a signal into this unit, get a signal out on the other side, and kind of watch and see what's going on. Otherwise, it's hard. Let me give you an example of what I'm talking about here. Okay, as you can see here on my oscilloscope, this oscilloscope happens to have some digital display meter settings on it. So I've got it set right now on voltmeter, and then I've got it set on peak to peak. So I'm reading the peak to peak sine wave out on this unit. And if you'll notice on the left channel here, I've got right at 1 volt. It's bouncing around just a little bit. But when I flip to the right channel, look at that. I'm at 1.2526 volts. So there's about a 25 or 26% delta in signal on the output of this amplifier between the left channel and the right channel, and that's what we're going to try to diagnose today. If you didn't have an oscilloscope, that's kind of hard to tell sometimes. You might be sitting there with your ear going, is my left speaker a little bit louder than the right speaker? I'm not sure. This gives you a visual, makes it real easy for you to figure that out.
Alright, so the next step in trying to diagnose what's wrong with this amplifier in my book would be to go out and find a schematic for this unit. And so I've downloaded the Scott 299D schematic. There's a couple versions, an early and a late model out there for it. I believe this is the later model. And so I've downloaded this schematic here. But I would say if you can't find a schematic for whatever you're working on, okay, it's not the end of the road. It just means the road ahead of you may be a little bumpier and a little more winding than the road without it. Imagine me going from here to maybe Myrtle Beach, and I'm going to rent a house, and for whatever reason I don't have a map and I don't have any type of GPS in the car. Doesn't mean I can't get there. I might just have to stop along the way and ask for more directions or instructions. And it might mean that I make some wrong turns and that I take some longer paths, but it doesn't mean I can't get to where I'm going. Same holds true without a schematic. You may end up having to find pinouts of tubes and looking at a tube saying, okay, this is a you know, whatever type tube, and there's pin 2, and I notice the wires going over here, and I notice pin 7, and I notice the wires going over here. Ah, that's feeding the filaments of this tube. So I know what that little piece of the circuit's all about. In other words, you end up reverse engineering the amplifier as you kind of work your way through it. And the more you do of that, the better you get at it. I troubleshoot a lot of things that even if there is a schematic out there, based on what I'm trying to troubleshoot, I may not even bother to take the time to look the schematic up. So you just kind of get good at it over time. But we've got a schematic here, and the first thing you may do is you may say, "Holy cow, Mark! Look how complex this schematic is." I remember in your other video on the single-ended KT88, that schematic looked pretty simple. This is crazy. And my response might be back to you be, well, just be glad it doesn't have an AM, FM, and multiplex section. It would be 2 or 3 times this complex. So this is some middle ground here on working on this is an integrated stereo tube amplifier. And what that means is it has multiple types of inputs. So not only does it have input for just auxiliary like we're feeding it here, but you've also got inputs for tape as well as phonos, which means this amplifier has a phono section in it. So just like eating an elephant, you too can break this schematic down one bite at a time, and we can kind of diagnose this thing and figure out where we need to go. So let me do this. Let me break it down for you and color code it a little bit, and we'll kind of take it from there. All right, this is the Scott 299D early schematic that I've kind of color coded and marked up to help you better understand it. And the way this amplifier works, when you feed into a series of RCA jacks on the back of the amplifier, right? Okay, so depending on the area here in the pink, what this is a series of switches, and all these little wafer things you see here that are kind of almost triangle or egg shape here. What those are, it's a series of ganged switches that are mounted onto the back of the selector knob that you turn on the front of the unit. So you may have 4 or 5 different devices plugged into this unit. You may have a tuner plugged in. You may have your, in our case here, we're plugging in a little iPod. You may have your turntable plugged in, and that selector knob lets you select between those. Well, if you happen to select phono, then it would take your signal here in this blue box. If you'll notice all these little inputs, this is mag 1 low, mag 2 low, mag 2 high, mag 1 high, ceramic, all these inputs here on the front. And this would be the left channel phono stage. Now keep in mind, phono signal teeny, typically about 5 millivolts or so, okay? That you would feed through it. So you've got to do a couple things in this little section right here. You would amplify the signal some, and you'd also kind of do your RIA curve if your unit had that built into it. But then coming out of your phono section, you would typically then be at a much higher voltage, much more in line with what would be considered line level, okay? And the same thing you'd have down here with the right channel. But if you choose one of these selector switch positions that was either the auxiliary, or in this case they call it extra or tuner, you kind of bypass that whole first section because you're bringing in a signal already as strong as the output of the phono section. So you don't need to run it through that super low voltage amplification back here in the phono section. So you basically come right out of this extra A jack and you jump right here into the purple box. And what this purple box is, it is your preamplifier stage. And there's a couple things going on in the preamplifier stage. You've got some buffering going on here. You've got some voltage amplification going on in a couple stages here. Ultimately, you've got your phase inverter here, this last little section of tube. And by the way, if you'll notice here, this is called V3A and V3B. All of this is taking place inside of one tube here for the left channel. Okay, if you'll notice over here, this one's called V2B and this one's V2A. So both parts of this are happening inside of one tube, and same down here, this is happening inside of one tube, inside of one tube. So when you look at this amplifier, really, this is a tube over here, this is a tube over here, this is a tube, this is a tube, this is a tube, and this down here is a tube, okay? The other things going on inside of this preamp stage, you've also got things like your rumble filter, your scratch filter, your bass and treble controls here. You've got your loudness switch, you've got your volume control. Basically things shaping the signal through this preamp stage, giving you some user selectable options, more bass, less bass, loudness control on or off, things of that nature. But ultimately you get this signal amplified to the right level you need to feed into your output. You feed it into this phase inverter here. You split the signal apart and you send it into this push-pull output tube stage here, which ultimately then one side of this tube, or one of these tubes here, would amplify kind of the positive peaks. One of these tubes would amplify the negative peaks of the signal, and ultimately those two signals get added back together here in the output transformer that feeds your output jacks. Okay, now the last section we've got going on here is we've got this green section. What this is it's the power supply section. You've got everything here from your filaments to the various, you got your rectification, your power transformer, your input, and basically you're just creating the voltages needed to supply the rest of this amplifier. Well, one thing you'll notice about the green box, there's not two green boxes, okay? So this is not, this does not have a power supply per channel. In other words, this whole green section is shared between both channels here, okay? Well, that's kind of good news for us as we're trying to troubleshoot here. For one reason, it's highly likely that the power supply is causing our issue. And the reason I say that is we've got a stronger signal on one channel than we do on the other. Well, the power supply is typically feeding both of those channels equally. So I'm not ruling it out completely. I'm just saying there's a high likelihood it's not the green section here. Just like extremely high likelihood it's not the phono section. I would say even a higher chance. So we can kind of mark out the blue section here as well. And I'm not going to rule out that the switching components here couldn't be affecting the signal, but the fact that we've already cleaned these switches with some deoxit makes it kind of highly unlikely that the pink sections are it either. So if you kind of rule out the blue sections, the pink sections, and the green sections here, we've already, without even getting on the bench doing much here, we've already ruled out half of this schematic that we don't even have to chase down at this point. Okay, so let's jump over on the bench and do a little more diving in, okay?
All right, what I've done now is I've taken the schematic and I've printed it out, but I zoomed in on it a little bit and I kind of cropped out this part over here to the left with the switches and the phono stage. Not that if we couldn't find a problem here, we might not come back to that, but it's highly unlikely that it's this section over here. And so what I'm now trying to do is break this down even further, kind of eat the elephant one bite at a time. And what I've tried to do here, what I'm trying to do is kind of create a demarcation point between my output stage here and the the preamp stage on the front end, okay? And if I can prove that somewhere right along in this section right here that the signal still has the problem right here, then what that would tell me is that I don't likely have the problem in the output section, and I can kind of rule out this part of the circuit at that point in time. So you know, I'm not saying I couldn't have a problem over one on one side and one on the other side, and but it's less likely. I'm assuming there's one problem at this point in time until proven otherwise is kind of the way I look at it. So if you look right before my chopstick here, up here you've got pin 6 coming off of this 6U8 tube or 6BL8, and you've got pin 6 coming off of this. And you always want to pay real close attention on these things to the tube name here. So this is V3A and this is V103A, so that you can kind of tell V3A, V3B, V103A, V103B. You know that these are in one glass envelope, you know that these are in one glass envelope. And I will show you here, if you flip the unit over and you found the 6U8 tubes, you would know that one of these is V103 and that the other one is V3. Okay, these are the two tubes we're talking about. So come back over here, kind kind of draw our demarc line again, and you're saying, okay, well, where we're going to look at the signal at here prior to this section here. And let me show you a little picture I drew for you. This is a kind of a generic amplification, tube amplification, little schematic I drew. And basically what it shows you is, and I would say this plays out for about 80% of tube circuits. There's a lot of variations and a lot of other different types of tube circuits, but this is by far, it may even be as high as 90% or more. What you see typically, you will see that the signal flows into the grid of a tube. So you can always tell the grid, you got a line, a couple little dashed lines. And then it will feed out the plate or anode up here, and typically you'll see two things coming out of the anode. You'll see a resistor that goes up, somehow feeds to your power supply or your high voltage B+. The other part will typically feed out through some type of coupling capacitor onward to the next stage of the amplifier. It's not always the case. There's other types of tube circuits. There's cathode followers. There's these phase inverter signals here where you take a signal off both the plate and the anode and the cathode here. But most voltage amplification stages look something like this. And this here happens to be a voltage amplification stage. Now this is a pentode tube in one part of the glass on these, and the other part is a triode here. So you kind of got an oddball tube here, in that part of the circuit inside the glass envelope is a pentode, part of it's a triode. The triode is used for a phase inverter, and it's harder to measure the signal coming out of your phase inverter because you've actually split the signal into two parts, the positive peaks and the negative peaks, to feed this push-pull pair over here. So instead of measuring here at the last stage before this, I'm going to back up one more to right here, this last voltage amplification stage. And I'm going to look at pin 6 of both of the 6U8s. And I'm going to compare the left channel to the right channel, see if they're equal or not. If they are equal at this point, then guess what we know? We know that all the way up to here our signal is being fed in equally, and then we've likely got a problem in our output stage. So we would have just eliminated all of this. If the signal is out of whack here, not equal in other words, then we know that likely our problem doesn't lie here, and it lies somewhere from here to here. So let's get some test equipment going here and let's figure that out. Alright, sorry, I'm using two different cameras, so the audio will probably vary some. But so if you notice here, I've got two oscilloscope probes, one with a yellow band, one with a red band. And I've got them both on pin 6 here of that 6U8, the last voltage amplifier stage there. And then I'm feeding them up into our oscilloscope here, and you can see, if I zoom out just a hair here, kind of the red and the yellow feeding in here. And they're both set to 1 volt on channel 1 and channel 2. And what do you see here? Looks like one of these signals is about 2.92 volts, and if I turn off it and measure the other one, it's 3.92 volts. So you can see the difference there in the amplitude of these two signals. So what does that tell me at this point? So what that tells me is we can rule out the output stage. Not saying, like I said, there's not another problem in the output stage, but I believe the fact that our signal coming off of the plates here of both this tube at the bottom here and this tube here at the top are out of whack tells me that this signal's somewhere between here and here, all in this purple box. And the good news is, hey, not only have we ruled out the output stage, we've also ruled out the phase inverters, because we know that that signal is out of whack before it even gets to the phase inverters. So let's get back over on the bench then and start working our way to the left here. Alright, here on pin 6 of the 6U8s, if you'll notice I put an X mark here. We are out of whack at both of these points. So let's jump back one stage now and come to the output here, which will be pin 1 here of V2 and pin 6 of V102. Let's look at the outputs of the tubes before that and see how the signal looks. So let's move that over. Okay, V2 pin 1, V102 pin 6. Let's scroll up here to the scope a little bit and zoom in. What is this telling me? Oh boy. Look at that. They're pretty much superimposed over top of each other. So somewhere between the output of these tubes and the output of these tubes, we have our issue, right? Somewhere in between, right here. So what I might do next, just to rule out these tubes, I might go here and look at the input of this tube. So pin 2 of V3, and looks like here pin 2 of V103. Let's do that. Okay, now pin 2 of both of these, which is the inputs here to these two tubes, right, is where I'm at. And let's scroll up here and take a look at our oscilloscope, and guess what we have? Ta-da! Let me zoom in just a little bit. As you can see, pretty much a perfectly slight little phase shift there, but perfectly superimposed signal on top of each other. So what it's telling me at this point in time is that somewhere between the input of this 6U8 on the pentode side and the output of this little tube right here, somewhere between here and here, we have our problem. Well, you might say, well, it's the tube. It's not. I've replaced both of these tubes. When we first got the unit on the bench, me and my buddy were playing around a little bit. One of the first things we did was kind of test the tubes and replace any that were that needed replacing. And both of these tubes are brand new in the box, matched pairs that I had matched myself. So it's not the tubes causing the imbalance. Well, if it's not the tubes themselves, what could it be? Well, it could be these components around the tube that are biasing the tube. And so we're going to leave the signal tracing world at this point, because we know the signal is good up to here and it's bad coming out of here. And we're going to enter into the voltage chasing world at this point in time. So I'm going to move to the top-down camera, and we'll figure out what's going on here. Okay, first up we're going to check the voltages going to both pin number 6 right here, which would be the plate on this tube, and the voltages going to pin 3 here, which would be the screen on both of these tubes. So if we come over here and we go to pin 6, 1, 2, 3, 4, 5, 6, I notice here, oops, I'm getting 88.5 volts, 88.7 on one. And if I go to that exact same pin on the other tube over here, I'm getting 93 volts. 88 and 93 on the plates of these. So definitely I'm feeding the plates differently. And if we look at the screens, which would be pins 1, 2, and pin 3 here, I've got 48 volts on this one, and 1, 2, 3 on this one. I've got 52 volts. See a difference there. So if the voltage here and the voltage here are different at this point, it could be because maybe what we're feeding into this on the other side here is off. So let's go measure up here at this point, which would be on top of the 150K or the 330K. And so if we get about right here, what we notice, 235 volts on one tube and 235 volts on the other tube. So, what does that tell me? That tells me the voltage I'm feeding, which ultimately comes across here, comes down and ties into this little bus line. And similarly here, comes out of here, comes over and ties into the same bus line. You can see right here where they tie together. My voltage coming from the power supply is equal. I've got 236 volts on one right now. I've got 235.8, 235.8. The only reason it's varying is the voltage in my house is varying a little bit right now as my furnace is kicking on and off. But you can see here 239.5, 230. Yeah, we're spot on here with our voltage from the power supply feeding this. So up next, what I want to do is I want to replace these these 330K right here, because that ultimately feeds down to the screens and feeds in, and this 150K that's feeding into pin 6 here. So let's see, 1, 2, 3, 4, 5, 6. Look, we've already replaced the 150 ohm resistors, it looks like. So let's start with these 330K and see if that solves our problem. By the way, before you start your soldering journey here, I would highly recommend you using a discharge tool like I've shown you guys how to make, and I would discharge all these filter caps. That way you don't somehow get down in here when you're soldering and get a nice surprise.
And like always, nothing is easy as it seems. Replacing the 330K ohm resistors really did not help, but hey, these were old carbon resistors, so you know, it was probably time for some new ones here anyway. They had drifted in value some, but that one ultimately wasn't the problem. So onward, we're going to keep digging.
Alright, so what I've been doing is I've been using a multimeter with the unit turned on, and I've just basically had one lead to ground and the other lead, and I've just been checking everywhere, and I've been comparing the left channel to the right channel. So here and here, here and here, here and here, you know, just everything in symmetry, checking back and forth on both sides. And ultimately what I found was that the grid voltage on this tube is different than this tube, as well as the plate voltage slightly, and I kept scratching my head on that. And then so next thing I did was I turned the unit off. I used a discharge tool and discharged all the filter capacitors throughout the unit, and then I pulled the tubes out, and what I did was then just started measuring resistances everywhere, and it was still kind of baffling me. And ultimately I had gotten to the place I was just taking a little bit of a shotgun approach, and I was replacing the resistors that had not been replaced yet, except for these four right here. They're measuring spot on at 16K because I was able to easily measure between the pin and the other side with the tubes out. So I was pretty much down to, I'd replaced everything, and yet these were reading well. So next, there's these 220 picofarad capacitors right here. And where they are at in the schematic, if you'll notice here, so when you come out of the plate of the pentode side of this, it feeds over, and what it does is it feeds the signal into pin 9 here of the triode section we're using as a phase inverter. Well, if you remember on one of these units, what I was getting out of pin 6 didn't match, you know, equally on both tubes here, the top one and the bottom one, but what was going in on pin 2 of the top and bottom was equal. Well, what I found was this little 120 picofarad capacitor right here apparently had shorted. So what was happening was my signal was coming out, coming down, and instead of going into the grid here of this tube, some of it was leaking off to ground down here, basically suppressing the output on this side and changing the load resistance here, going to this V3. So ultimately, when I replaced these 220 picofarad capacitors right here, this one and this one, all things came back to normal, and I'll show you here what I'm seeing now. Okay, you can see it now. Look at that, perfectly superimposed over each other. They vary with the volume well together. You can see slight differences throughout the variations of the volume pot, and that's just because the volume pot's probably not identical throughout the sweep on both sides of it. But as you can see, and not sure if you can see over here or not, but this is distortion measurement on this, 0.2% distortion. This unit is it's looking amazing at this point in time. So at this point, I'm just gonna, I noticed the unit had only 2 of the 3 bulbs in it needed for the kind of the stereo indicators and whatnot on the front of the unit. So I'm gonna go ahead and fix those as well and get this back to the customer. Look, at the end of the day here, my goal was not to exactly show you how to fix this unit. I'm probably not going to title this "How to Fix a Channel Imbalance." This was more about how to eat an elephant one bite at a time and how to break this unit down and kind of narrow down where you needed to focus, and ultimately get you to solving the issue without having to troubleshoot the entire amplifier from one end to the other. So hopefully you learned a little something, and I know I did. I tell you, after I got that set, I went to bias the outputs of this unit, and these are always tricky little units to bias the output of. Maybe I'll make a video on that next. But thanks for watching, everybody.